So our last section of material is linear and absolute value inequalities. So inequalities are less than, greater than, and technically the not equal to is an inequality as well. The ones that we're going to focus on are going to be the greater than or less than type of inequalities. So we're going to look at how we express the intervals first. So there's three ways of talking about an interval of values. You can look at the set notation, you can look at the interval notation, and you can look at the graph. So on this one right here, if your set notation is that it's greater than or equal to A, I'm going to jump over to a graph for the moment. What that will mean is that there's an A somewhere on your graph, and the values are supposed to be bigger than A. So in terms of, highlighting or shading in or whatever on your graph, it's these values. These are the values that are bigger than A. If there's a line underneath it, you will have a bracket, like so. If there's not a line, you have a parenthesis. Line bracket, no line parenthesis. The graph actually lends itself very well to the interval notation because it tells you where it starts. In this case, it's a bracket at A. And it tells you it never ends, which means it goes on to infinity. Infinity always has parentheses because a parenthesis means I can't equal the value, and infinity is not a value, it's a concept, right? This idea of continuing to move along. Now, let's just go from the interval notation here and do the graph, since we've been talking about the graph part. So on this one, we have an A again. The difference here is that the A is the ending point, so that's a parenthesis opening like this to match the interval, and the shading will go to the left. Okay, so it's from negative infinity, the left-hand side, stops at A with a parenthesis. Are these values that are shaded in blue bigger than A or smaller than A? They're smaller. So what I've actually represented over here is the A values that are the values that are smaller than or less than, I'm sorry, I didn't write that right, X, there we go, are smaller than A. So these are all the values that are actually less than A. And I don't have a line underneath it because I have a parenthesis, not a bracket. Now our third type is that we don't have anything going on to infinity. It's actually contained between two values. Now the interval notation for this is super friendly. The interval notation actually looks just like the graph. I start with a parenthesis, I end with a bracket, A is first, and B is second. The set notation, or the inequality notation, has the A and the B in that same order, and X is in between them. Now there's a parenthesis on A, so there's no equal sign. There is a bracket on B, so there is an equal sign underneath the part equal to B. Okay, so that's stuff you've seen before. Those are concepts that are presented somewhere in middle school for the first time anyway, and then you kind of keep touching back on it throughout high school. So I know you've seen that before, but maybe it's been a little bit. Why are we doing it, I guess is a good question. It's because the way we express our answers needs to be in one of these forms. And we're sometimes asked to put it in set notation, sometimes we're asked to put it in interval notation, and sometimes we're asked to draw graphs. So that's what's happening on these particular problems to start with. They're just asking us right now to express it in those three forms. So this one says that the x is greater than or equal to square root of 3. I always like drawing graphs first. That's my thing, because I'm a very visual person. So I can put the number on here, square root of 3. And am I going to shade to the right or to the left? To the right, because it says their values are greater, right? This is a greater than symbol. So I'm going to shade to the right. Am I going to use a parenthesis or am I going to use a bracket? A bracket. Why? Right, because there's an equal sign underneath it. So this is the graphical notation that I'm trying to present. And then the interval notation mirrors it. I start with a bracket. I do a square root 3, my comma. It keeps going forever. That's infinity, and infinity always has a parenthesis on the end. Number 2. Number 2 starts out in interval notation. But again, I'm going to be the one that's going to draw a graph every time because I can put whatever numbers that are on the interval on my graph. 54 is the only one. And then, am I going to shade to the left or am I going to shade to the right? The left, right? Because the 54 is the ending part of that interval. And will the 54 have a parenthesis or will it have a bracket? A parenthesis, because it had a parenthesis in the interval. And the parenthesis always opens towards the shading. I didn't think I actually said that before, but it always is encompassing the shading, so that's why it's opening that direction. And then in terms of a inequality or a set notation, this tells me that the x value is less than 54 because it's in front of 54. And there's no line underneath it because it's a parenthesis. So we're doing this so that we can actually take an inequality and then we can solve it. That's why we're doing it. So we solve inequalities in very much the same way as we solve equations. There's one caveat. I'll show you when it comes up. So we add and subtract, we multiply and divide, all the same things happen. So the first thing we would do here is what if we're trying to solve for x? Yep, subtract a 1, you bet. So I have 2x on the left, and I have a 5 on the right. Yeah? And then what would I do? Yeah, I divide by 5, or 2, excuse me. So x is less than 5 halves. You can leave it as 5 halves. It doesn't reduce. If you really want to write it as 2.5, more power to you. Doesn't bother me either. That's fine. But 5 halves will work. The graph asks, or the statement asks us to solve and to graph. So we have solved, and now we need to do a graph. We don't actually have to do an interval notation because it didn't ask for it. So I won't. Here's my 5 half. Do I shade to the right or to the left? The left, because it says less than. Will I have a parenthesis or a bracket? A parenthesis, because I don't have the equal sign. Now, just for good measure, because some of your problems will ask you, what is my interval notation? Negative infinity. And parentheses, right? So if it asked you for that, that's what you would do. Okay, the next one shows the caveat to inequalities that I mentioned before. So let me show you what happens. And I'll show you when it happens. What would the first thing that we would do, what is the first thing we would do to solve this for x? Yeah, I'm going to multiply by a 7 because I'd like to cancel the 7 out of the denominator, right? So these 7s will cancel. It gives me a 5 minus 3x. And what's 2 times 7? 14, yeah. What's next? Subtract a 5, you got it. So, what's 14 minus 5? 9. Okay, here's the catch. What do I want to do? Divide by negative 3, right? I mean, that is what I'm supposed to divide by. When you multiply or divide by a negative, some of you are already saying it, so tell me what we're going to do.
Switch the sign.
Yeah, we switch the sign. So previously, or currently, the problem it says greater than or equal to has to change to less than or equal to. So I still have an x on the left. 9 divided by negative 3 is a negative 3 on the right. So my x is less than or equal to negative 3 on that one. And it happens not with adding and subtracting. It's only multiplying and dividing by a negative. And there's a reason for it. It's very straightforward. But if you think about having a value, let's just do some numbers real quick. So let's just do 1. 1 is less than 5, right? All good to go on that, no problem. But what about negative 1 and negative 5? Which one of those two is bigger? Yep, the negative 1 is. So you multiply by a negative 1, you change the sign. So that's just a concrete, simple one. This one still says to graph because the directions are still back over here. Sorry about that. So we're going to graph the solution. I have a 3, negative 3. Am I shading to the right or to the left? To the left. Parenthesis or bracket? Bracket. And just for good measure, what's my interval notation?
Parenthesis, negative 3,
Right. Okay. This one has two inequalities, and they got the word and in between them. The word and means that it has to be a value that works in both of them at the same time. That's what the word and means. So we're going to solve both of them, just like we have been. And then we're going to have to analyze what the solution is to figure out what works for both of them simultaneously. Right? It's got to work in my schedule. It's got to work in your schedule. Otherwise, we never meet in my office. It's the same thing. You're trying to satisfy two conditions. So we'll subtract our 5. Negative x on the left. What's 4 minus 5? Negative 1. And then we would divide by a negative 1, which does what to the sign? Flips it. And then negative 1 divided by negative 1 is 1. So I've got x values bigger than 1. Let's do the other one. I'm going to add my 5. 0.2x. Let's see. 1 plus 5 would be 6. What would I do for the negative 0.2 now? It's not negative. I don't know why I said negative. The 0.2. I would divide. Yeah, thank you. 0.2. I think I was thinking it's not negative. I'm not going to change my signs. I think that's what I was thinking. All right, and then 6 divided by 0.2 is 30. Okay, so I have a value 30. Calculator works just fine to find it. So I need a number that's bigger than 1 and smaller than 30. So if you think about graphing this, it's the easiest way to actually find the answer to this. I need the number 1 and I need the number 30, and they have to go from left to right in order. The number needs to be bigger than 1, which means, in theory, I should be shading to the right side of 1. And it's supposed to be less than 30, which means I should be shading to the left side of 30. That was a terrible color to choose. Let me try it again. Let's try blue. Left side of 30. So what should the answer be to the question? The part in the middle, right? It's supposed to satisfy both at the same time. So the actual graph should have looked like only the shading between. And then I need to be careful with the signs. So this one doesn't have a line underneath it, so it's a parenthesis. Neither does this one, so it's also a parenthesis. And if I looked at my interval notation for this, what would it look like? 1 to 30. Okay, so here's what's happening. Homework for 1-6 got to be done by next class, okay? Homework from 1-7 will be pushed into Monday, but here's what you need to understand. We're going to finish, and we have a quiz on Friday as well. It won't include 1-7 because we haven't finished 1-7. So it'll include 1-4, 1-5, 1-6, 3 sections, okay? 3 sections of the homework. I will finish 1-7 in class. I have like 4 more examples. It won't take us very long, and we will review. So quiz, finish 1.7, review. 1.6 is due on Friday. 1.7 will be due on Monday. Is that clear? Awesome. And it's recording, so if you need to get those instructions again, just listen to the end of the video. All right? See you guys on Friday.